Welcome to another lesson with Dr. Powell. Let's have some fun with polynomial multiplication and looking at application and rolling a die. One time, and then a second roll, and then a third roll, and then a fourth roll. And we're going to count how many different ways there are of looking at the number on the die that comes up on the roll and seeing if it's larger than k when we're on the kth roll. And we're going to count how many different ways that's possible of happening amongst four rolls. For instance, if we're on the first roll, we're looking for, let's just look at this one in particular and answer this question right on the first roll. Well, it can only happen at most once because it's only one roll, and it can happen not at all, perhaps. So we'll notate that with exponents. 1 for happening once, and 0 for happening not at all. Now, how many ways can that happen? How many ways we'll write as coefficients or a frequency. So how many different ways can this happen? Well, let's think about this. If you roll a 2, 3, 4, 5, or 6, that's 5 different ways of it happening because all those numbers are bigger than 1 and we are on the first roll. Now, if we roll a 1, 1 is not bigger than 1, so it wouldn't work. That's only one way of that happening. So this would be like a polynomial committee, if you will, of what is actually happening and how we count things on just one roll. Now, for this next roll, how are we counting things there? Well, it could either happen or not. And it happens when we roll a 3, 4, 5, or 6. That's 4 different ways. It doesn't happen when we roll a 1 or 2. That's 2 different ways. Similarly, we can write a polynomial down for the third roll and the fourth. Now, what we're looking for is how many ways this could happen, maybe exactly 2 times. Now, in each roll itself, at most it only happens once. However, amongst all of them, it could happen twice. How many different ways? Well, let's think about it. One of these could happen in the first roll, or one of these, or one of these, or one of those. How do we pair all the different options together? We do it using polynomial multiplication, which does the distributing of options perfectly. So we start. Let's multiply these two together. And we're going to use the regular multiplication algorithm for whole numbers that we learned in elementary school, because instead of 10 or powers of 10, we have powers of x, but it works the same way with place values. We could use FOIL perhaps, but using this enables us to keep going in the multiplication in further steps. And we're also just going to simplify it a little bit because we only need to look past no further than the x squared place. So this would be like the constant place, the x squared place. We multiply using this algorithm, which takes care of distribution perfectly. 2 times 1, 2 times 5. And then when we multiply by a power of x, it shifts all the exponents up 1. So we start writing here, just as we would in the normal algorithm. 4 times 1 is 4. 4 times 5 is 20. We add 2, 14, 20. Now we continue. Let's multiply this one right here, 3, 3 to it, keeping in mind we don't go past this place. So 3 times that whole row right there is 6, and then 42 and 60. And then this whole line just is 3 again multiplied to that, but just shifted over. So 642, and we can stop writing because we don't need to go past there because that's the x cubed place. Now we add again. So 6, 48, and 102. Okay, now for the last multiplication. 102, 48, and 6, and 2, 4. Keep in mind the most important thing that we need is what happens right here. So let's concentrate on that right now in this final multiplication. Really what we're going to get is we only need to get this thing and this thing right here to add together. So 4 times 102 would be 408. And then 108. And then we actually, because of shifting, on the next one, we just do 2 times this one, which is 48. So 2 times 48, which would be 96. Now, when we add these two together, we're going to get 504. So this tells us that there are precisely 504 ways of this happening exactly 2 times amongst 4 rolls. Thanks for watching.